Shimasei, and welcome to Tinker Tailor Soldier Fry here on the mighty Loading Ready Run Video Entertainment Network. My name's Ian, and we've got an Alex with us today.
Yoroshiku onegaishimasu.
As always, we got Paul running the ones and twos in the Crystal Gondola.
Ones and also twos.
Yeah, ones, twos. We've got a fair number of channels, not quite 32, but you know we're making it work. And of course, we have a new large friend here.
I haven't named it. I mean, I don't know that I would name it. But
what would you name a gambling accessory? Before we get to any of that, though, we do need to remind you that everything that we do here on the channel is brought to you by you, our kind patrons, over at patreon.com/loadingreadyrun. You are the reason that we get to do this every 2 weeks, and we thank you greatly for it and for all the support that you show for the channel on the Patreon, at twitch.tv/loadingreadyrun, youtube.com/loadingreadyeverything, and I mean, we really should just grab that. And of course, over at store.loadingreadyrun.com, where you can get yourself some things that will decorate your life and show others out there how much you love supporting Loading Ready Run. Alex.
Hi.
What do we have on the table here right now?
This is a 1973 Nishijin Pachinko machine.
1973.
Yeah, it's a lot older than you would think. So,
hello.
We should probably explain what Pachinko is. It's Japanese vertical pinball is the simplest way to talk about it, but it's also like a cultural phenomenon. I want to say it got started in like the 60s.
That sounds about correct.
Yeah, that sounds about right. And it's a bizarre little thing because the way that it works is maybe it's better if I just show people.
So did this come out before Peggle or?
I mean, in terms of addiction levels, you could say this is the OG Peggle.
Yeah. So the way you play this game is you go to your Pachinko parlor where they have dozens of these, and they sell you a number of balls. Do we have an angle that I can?
Yeah, I'm gonna get you in there.
Bit.
Just want to just tip your hand there a bit.
So they will sell you some number of these stainless steel balls, which kind of form your points and ammunition for the game. And so you bring it around to the machine, you put it into the play tray here, and on the early versions like this one, play was entirely manual. And so you'd park yourself in front of here, maybe get your cigarette going in this ashtray.
A literal actual ashtray.
And then away you go. So the lever, you just pull it down, release it, and it will fire one of your balls into the playfield. And what you're trying to do is hit one of these targets here, which I will attempt to do. And if I can't, I will cheat.
Unleash hell.
Now imagine like 100 of these going at the same time.
Right. I'm just going to go ahead and give a headphone warning right now. Things might get a little noisy.
But yeah, 100 of these all in a row, like right next to each other. Each one of the people at each of the Pachinko machines smoking chain style.
Yeah.
What's amazing to me is that
I haven't hit a single one. I never said I was good at this.
I don't know if anyone is good at Pachinko.
I think this game gives a great illusion of it being skill-based.
So you have managed to get at least 4.
So these are the lower tray is where it returns balls if they don't clear the playfield. Like if your shot is too weak,
they just come out through there.
It refunds it to you.
Okay.
So you know what I think we'll do just to demonstrate.
Ian, could you maybe move the right hand, like camera 7? I think I might have a better shot of the front of the...
Yeah.
So if I was actually like accomplishing something, you would get a ball into one of these. They're called tulips.
Oh.
Oh, and they open.
Yep. No, that didn't fire for some reason. And it'll pay out 10 balls at a time. And you'll also notice that they opened. The middle one and the right one opened. So that means the next shot will be easier. But then they close again, so you can get it. So there's 10 balls again. And then there's like this really, really hard to hit one right up at the very top, which I believe might open all of them. So you can, that's basically the game. Is like you shoot balls in, you try to score, and you try to come out ahead. And then when you've gotten sick and tired of playing it, you hit that latch. And you can take these either to the next machine or to the front counter. So this is where it gets interesting, and I'm sure Ian can help me with this. So a pachinko parlor is sort of set up like a Dave & Buster's, where you can exchange those balls for like prizes. You know, like at the time would have been like candy, cigarettes.
Oh, absolutely. Cigarettes, home goods, like small
home goods,
appliances,
little,
radios.
like, toys,
Yeah.
stuff like that. But also, so Japan had and still has really stringent gambling laws. But Pachinko specifically found out I hesitate to call it ingenious because it's pretty obvious, a way to skirt those laws, where you can take, at like every Pachinko parlor, there is a definitely not affiliated with it.
In a separate building.
In a separate
very
building,
specifically.
around the corner that nobody will directly tell you about, but everybody knows about, where you can take your winnings and exchange them for cash.
No, you're selling used, pre-acquired goods. Be very clear. You're
that's
not
all above
exchanging
level.
anything for winnings. No, you're selling things, yes. And
so that's how it became like this sort of gambling phenomenon. Is like this weird little loophole where you could play for cash, and then it sort of is a little bit like playing slots with a couple more.
And as you can see,
steps
it's
involved.
extremely easy to get to.
Yep, you could just park here, hide from your wife all day. It's like there was a documentary I actually watched by the BBC in the 60s talking about this craze and how when it got to like its fever pitch, they actually started implementing things to try and slow people down. Like there's some machines where you have to feed in balls one at a time by hand. Like you don't even have a reservoir.
No, there have been various tricks, and going around the other side, modern pachinko machines are operated by a knob that you turn to adjust not necessarily the speed of individual balls, but just to change the rate at which they fire out automatically up into the machine.
Yeah.
And the pachinko industry just is a licensed goods mega theme park. You know, if you want a Macross Pachinko, we got it. You want Urusei Yatsura Pachinko, we got it. You want Evangelion Pachinko, they will never end.
There's the big joke a while ago that that Konami was getting out of making video games because the Metal Gear Solid Pachinko game
series
was more was making more revenue than the Metal Gear Solid video game.
Now the weird thing is that the Yakuza games do include pachinko parlors, but in the North American versions, for some reason, I guess it's gambling reasons, they disable them. So you can't play automated pachinko in the American Yakuza. That does look really cool.
So in America, you have to do it manually?
No, in the American Yakuza, you just can't go into the building.
Hey!
Hey, big winner!
So that's great actually because it demonstrates how it's able to queue up wins. And we'll get to the second part of this. Yeah, it's basically like pinball crossed with slot machines.
Yep. That's a really good.
And just to be clear, the machine makes a ton of noise, but if you notice when there's no noise right now, because there's no electronics other than a light on top of it.
So, would you believe this machine is entirely mechanical and has no electronics except the lights? So we're gonna take you around. I'll just turn it here.
Yep. I'll
Like
get the
this
camera.
was a really fascinating part to me. Is there's nothing that runs the machine. It is all.
It's not even electromechanical. It is
No.
just mechanical.
It's all just Rube Goldberg stuff.
So the thing that those wires are for is to light up the lights.
Yeah, so I have a 9-volt connected to the lighting system, which is 2 indicators on this. So like there's a 9-volt battery here that I think they would sometimes have these plugged in, but I just like put this in for convenience sake. And so that works for the prize light there, which I upgraded to an LED, like a high bright LED, because why not? And also the machine empty light, where and I'll show you in a second after making the loudest noise in the universe, that when it runs out of balls, it will light up so the attendant can see that it's no longer available. So yeah, like all these wires and so forth are just for those 2 lights. Other models have more lights for different displays. Like I think the molding for here has like little places where other stuff could be, but this is like a pretty bog standard kind of model. So how does it work? So up here you have a big kind of trough. You can't quite see it, but it's like a sort of slope trough full of play balls. And they come down this chute here. Underneath these little swingy things that level out the flow into like one flat layer. And then I believe this part also maintains that that's being flattened into 2 rows here that go around the corner into this segment, which separates it into 2 flows. So there's like one here and one here. Just like close that. So these are all like little spring latches and so forth. And so that primes the prize payout system, which is here, I think. Like, I might actually take the cover off. Let me see.
Why the 2 streams?
That's a good question. Like a lot of the inner workings of this I don't fully understand because they're like kind of weird voodoo stuff. But the basics kind of make sense to me.
I've seen for whatever reason, I feel like there's been in the last couple of years, there's been a trend of various sort of YouTube maker types trying to build things with ball bearings, like making like a clock that does ball bearings and all this stuff. And
the ill-fated Wintergatan marble machine.
And to a person, they basically all go insane as they attempt to like every single project becomes like this multi-part thing that becomes larger and larger and larger.
I need a thin screwdriver.
As they attempt to deal with
I think we have
the reality of dealing with ball bearings, which is
they don't behave
as precise and they get jammed in different things. And
yeah, I'm gonna open this up because it's all like it's wild because this thing is actually like made out of wood and plastic. Like the machine itself is thank you. Perfect. Has a wooden frame and it's actually set into the frame surrounding it is something that I made to display it.
Oh, okay. I was wondering, like, how much of this is like the original state that you found it in, and how much of it is your modifications.
Very little is my modification, and I'll do my best to show you. There's the screw.
Little is the modification that goes in.
So yeah, we can see the prize payout system here. So
So it's loaded up 10 balls there.
yeah. So when you get a jackpot, it'll pay out 10 balls. So I think it's like 5 and 5. Maybe it's adjustable or something, but.
And so there's various ways that lever can be triggered, though.
Yeah. So for when I was saying earlier that it can queue up multiple wins, I believe that's this system here. Which I'm going to carefully. Okay, there's more screws there.
Don't take it apart so much that it's not.
Yeah, no, I've had this apart before. I'm just very careful about, getting it. There we go.
Now, normally in like a pachinko parlor or whatever, these will be sort of embedded in a wall so that the attendants would be able to access the back.
Yeah, they would have like a little gallery behind them, so they could go and like refill them. And I think the wiring diagram includes a provision to have the indicator go to like a central location where you can tell it's like, oh, number 16 is done. So you have here a little balance beam where like if you get multiple jackpots, it will queue them up. I think that's how it works. Let me
just tilt this a bit more.
Yeah, go for it. Like so?
Yeah, perfect. Thank you.
So I'm gonna see if we can watch this thing as I pay out a couple of jackpots. Let's go. Neat, huh?
Very cool.
Cool.
Yeah, so like it's all based on like gravity.
And just like the weight of the ball bearings.
Because like it's starting at the top and going all the way down to the bottom. So you have like return chutes where like if you miss, it'll send it into the sort of return tray here. Because like it's not perpetual motion, of course. So like eventually everything's that starts at the top is gonna end up in the sort of like used sort of return area or with the player. And you've even got like, I think this is the bell here for when you get prizes. They just like rattle past it. Oh, maybe not.
I love that it's like there's the pachinko actual face on the other side, and then on the back here there's almost like a separate parallel pachinko game that the balls are playing.
It's wild.
That's like a completely just as complicated, if not more so, as what's on the front.
Yeah. So let me do something real quick. I'm just gonna put this back where it belongs.
Somebody in the chat mentioned that you also posted some videos of this on your Twitter, eh?
I did. I don't really use Twitter now, but I should repost them on my Blue Sky. Because this was a really fun project. There was not, as I said, there was not too much to fix or restore, but there was a fascinating process of learning. So I'm going to make the loudest noise in the universe, so you will probably need to
I'm gonna
take the mics down.
Okay.
Pull down the mics a little bit.
There is actually
You're gonna reload it, or you're gonna.
So the keys open the front, and I'll show you that in a minute. But there's also just like this pin, which you can't see, and there's a little hole on the front of the machine where if you press it into it.
Well, that wasn't so bad.
Yeah. So now
The loading was the loud one.
it's true. So now you'll see that this light is on, which indicates that the machine is out of balls because there's actually a scale here. So like when there's actually balls in this area, it will press this scale down and release this little leaf switch, which has like it's like reverse wired so that like when it's filled, it doesn't have a connection, vice versa. So I had to clean those a bit because they're very fussy about it.
So the having the sort of balance and everything. So like, not only, it's like it only works with like these specific size and weight of pachinko. Like they're very precise.
It's pretty close. Yeah, I think if you had slightly out of round or weight balls, it would probably just screw up the machine.
Well,
they would get like jammed and stuff like that.
the other thing too is that you need to win so many balls to be able to prize out or get any real cash out of them, that I don't believe that there's any benefit into buying counterfeit balls and bringing them to the pachinko parlor to play
although
with.
I will tell you, when we turn this back around, this is probably going to be real loud.
Okay. It's I think you were supposed to lock that off.
Yes, I forgot. You need to close that latch first. Okay, fortunately, a bunch of them were there. Oh boy.
It reminds me of the time when I.
Wait, what was that?
It reminds me of the time that I was cleaning the trap on my sink. And so I pull out the trap and I empty it out, and so I have this big bucket of dirty water.
Oh no.
And of course, I'm like, well, what should I do with this big bucket of dirty water?
I'll put it down the
I'll
sink.
put it down the sink, of course.
Yeah. Awful. Okay, so now that we have everything back as it should be, I can show you a few more things around the front.
Ooh, wait, I'm going to move your various detritus here.
Thank you.
People in the chat were talking about how it's interesting because it has like some skill aspect to it.
A little bit.
And I mean, I think this is that sort of ideal kind of midway
Exactly.
game thing,
Like I said,
where it feels like you have more control than you actually do.
exactly. I think that's why it's such a successful game, is because it really seems like you're so close to controlling it, and you're really not.
And I mean, these days they do that same thing. They do the same thing, but they do it like digitally. Like those things that like where the light spins around. Mm-hmm. I remember somebody did a test where the thing with like the light spins around and you hit the button. Somebody did a test using high speed camera and stuff and be like it actually like just doesn't stop.
Yep.
Like regardless of how much you dial it in. But like that's just like a computer thing where it's just it's just actually deliberately lying to you. Whereas this is basically doing the same thing, but it's doing it in a sort of physical way rather than a digital way.
It's actually a pretty fascinating design, which is pretty par for the course for the kind of things I'm into. By the way, this little trough down here is not part of the original design. The machine itself is just this thing. The plywood on the outside, and this lower part is a sort of like cabinet that mounts to the wall at my house when I have it there. So let's have a look.
I do also want to point out that we have just received a warning from my watch that if we maintain these levels of loudness for more than 30 minutes, we can get hearing loss.
Yep.
So yeah, Apple Watch not calibrated for pachinko parlors. Clearly.
Not in the slightest.
Now, in hindsight, I probably should have just done this from the start, or maybe not.
Are you all right?
Yeah, I'm good.
Okay.
I just gotta hold this. So yeah, you would be, because this would be in the wall. You would normally be able to swing that open. I'm gonna close that again, and then I can show you the rest of this. But yeah, the attendant would be able to open the front that way, and then they would be able to do maintenance stuff like opening the lens.
That's
which,
pretty impressive.
interestingly, there's 2 panes in here. There's a, which one is glass? There's plastic and glass. And the reason for that is to keep people from cheating using magnets. Because otherwise you would be able to like magnetize the balls.
Right.
So it just needs to be a certain thickness.
Yeah.
I mean, this was before rare earth magnets were readily available.
Yeah, I would think so. Could you pivot the camera down just a little bit?
Absolutely.
Like you could 100% like that would not be thick enough anymore.
So like everything just opens up for maintenance. And you can see some more of the inside. Like that's the little hammer that kind of propels the ball there. So like, wank, see ya. And it would be feeding from here, but it's all open. So it's like if you had to do like routine cleaning or whatever, which is probably what I'm going to be doing for the remainder of the stream, you could do that. There's also like, because it's extremely Japanese, there's a bunch of weird little remarks on it. Like if you zoom in down here,
Yes.
if we can focus, it's a beautiful day. It's a beautiful day.
Now, I think someone in chat was sort of figuring this out, that you have plastic and glass. So you have glass on the inside so it doesn't get scratched by the balls. Maybe you have plastic on the outside so that people can't break it.
Possible. I mean, I'm sure there was like a lot of justification that's been lost to the sands of time, or just like I haven't discovered in research yet. I also heard anecdotally that the glass on the inside increases the amount of noise, which is like...
Is like intentional?
Yeah, because
it attracts, like, so people can hear where the parlor is from
Yep.
outside. Now, all that stuff up in the corner is just kind of
just
decoration.
clear plastic.
It's just decoration there.
Yeah,
right?
but like that's where the little indicator says that it's like empty. But yeah, the rest is just decoration. I think there's spots for this stuff because this looks like it should have lights, and there's actually like
Yeah, it looks like that's like some sort of scoring thing.
there's on the actual back there's little areas that haven't been used where lights could be mounted. So
this is
I
maybe
bet
like
you-
a generic.
yeah, there's probably versions where it has more lighting. But like I said, this one was like pretty just like typical of the time, you know, just very, very standard.
Extremely cool.
So yeah, this was a lot of fun. I think it was like one of my used Victoria or like Facebook Marketplace finds.
So Google says the inside 1/4-inch plate glass or 1/8-inch plate glass is for sound insulation.
I'm not sure that is working the way they want it to.
Maybe you do have it very open in the back.
That's true. That's
Yeah,
true.
that's possible.
Yeah.
I mean, I don't know what the acoustics would be like. Oh, also I added this. If you can pan up to it, if we can get Ian's camera. Yeah, this is like a picture. It's like a picture light.
Yeah.
Because you want to be able to see what you're doing, and the hallway that I have this displayed in doesn't have its own lights. So there's like all kinds of wild stuff about these, like specific tools for driving the brass nails in and for like adjusting them.
And I bet that like the different patterns of brass nails have like special names.
Oh, I'm sure they do. Yeah, I polished a bunch of these as best I could. I think I might do another hand polish at some point. Because the first time I went over it with like a Dremel and Jeweler's Rouge, and then I got Jeweler's Rouge everywhere, and that wasn't so great. So I would probably just get some Brasso and like spend an afternoon like thumbing them. And I sort of started restoring some of the paint on some of these. Like I redid the silver on here because it's a little worn away. I think I should definitely redo these wheels.
Does that say SOS?
I think it says SSS, which probably doesn't mean anything at all.
Just like super.
All of these directions are south.
This
Opa.
reminds me my favorite gambling factoid is that slot machines, especially ones in like Las Vegas that are, ooh, nice. The slot machines that are covered by the Las Vegas Gaming Commission are legally have no skill aspect to them.
Interesting.
So no matter what it shows you on the little video screen, whether you're playing a pretend poker game, whether you're playing whatever, the moment you have put your money into the slot machine, the outcome has been determined by a complete random thing. So what it shows you on the screen is
it means nothing.
It's a reverse, like it just basically reverses it in order to get you to the outcome that it has already decided.
Wow.
And that's not like a conspiracy. That's legally how they have to operate. They cannot have a skill aspect in order to be considered a slot machine.
Yeah, I mean, the running joke was always like, the lottery is a tax on the stupid, which is, cruel. I think it's, more like on people who are just, I guess, gullible, which is a shame because I think it kind of preys on, vulnerable groups like everything else.
I mean, like my grandpa loved to go to Reno and play the slot machines, and he was a very frugal type, and so he would play like the really cheap ones, and he effectively just like, I don't think he would have considered it that way, but he was effectively like, a gamer, like he was
a professional gamer.
Well, but like he was playing it like he was doing it because they were the most entertaining ones, and he was basically just playing a video game, like.
Yeah,
I think he never really got into computers and stuff, but I think if he had a phone and he had gotten into or an iPad or something, he could have just, it's like you could just play that. You don't have to put the money in. You could just play Balatro or whatever. Play video poker.
Where the heck?
You're allowed to do that.
My cleaning solution leaked all over my bag.
Oh no. So what I'm doing here right now,
I'm gonna go find some water or cleaning stuff.
Go for it. The other thing I was going to plan to do here today, in addition to the sushi, and I think we have just enough time to either get it done or get it started, is I figured it might be fun to walk y'all through putting together the circuit that I used for the Desert Bus Random Dance Party button that controls the breathing function of the LED. Because I think it's a very simple circuit, and it's a lot of fun.
You mean it? Deidre wasn't alive?
Deidre was absolutely alive, yes. But electronically alive. A very different.
I mean, it is amazing, the dance party button, has had all sorts of, you've made all sorts of different things every year, and they have all attracted attention in various ways, but it's amazing how much just that little aspect of the pulsing button, the pulsing light, completely changes the way people interact with it, and the sort of the way people interpret what's going on. Plus a big dose of desert bus weirdness, of course. But
Yes, no. When I said I made it friend-shaped, I was definitely trying to prime people's minds to think of it anthropomorphically. Because otherwise, it just looks creepy. So, we don't need much at all for this circuit. We're going to build it on our little breadboard here, or whole board. I don't
Why do
remember.
they call it a breadboard?
Well, the other ones are bread colored, and I think those are the actual solder. I think these are just prototype board things.
I've always heard this style still called a breadboard. But
I'm unsure. So all we need for that is 1, not 50, NE555 timers.
oh, I have heard of these timers.
Yes. If you post a microcontroller project to the internet, you will probably be told by one or more grognards that you could have done it with a 555 timer.
Oh no. One
And-
of those components.
Yeah, it's one of the wonder components. They're kind of great.
So did you say you have a pack of 50 of them?
Yep. This is something I was talking to Alex about before the show. The problems with electronic components and buying reasonable amounts of things.
You can't.
I could have bought 2 555 timers for $10. Or I could have 50 for 12. And I figure, you know what? I will probably have enough of these that I can give them out as candy next Halloween to the children that don't show up, or I'll just have enough left over for all projects in my life going forward. I don't know why I'm trying to save the plastic, but just need to get in here to one of the
Ew.
chip sides. There we go.
So what is the 555 that is of the 555?
So I'm not sure what the 555 is a referencing. I think it just might be that's the indication that this particular chip got given when it was designed.
Oh, it isn't that there's like 5 somethings on it?
No, I don't believe so. It does have multiple modes that you can put it into based on configuring your pins and which pins are touching which. We'll be using, there's a stable mode and there's 2 different types of unstable mode. Oh, there we go. Thank you, the Maricat. It says that the 555 timer is named after the 3 5-kilo-ohm resistors inside its internal circuitry. But the name was actually chosen arbitrarily by the marketing manager at Signetics Corporation. So there we go. It's it does mean something, and yet it was chosen arbitrarily. So let's slide one of those down here. But it's just an 8-pin chip that can be configured into various different modes to do a lot of different things, like flip-flopping and counting up a register. So you'll often see 555 timers used in things like those Cylon or what do you call it? Knight Rider LED strips. So we'll need that. We're going to need an resistor as well, or a couple of resistors.
Tell the joke.
Okay, so come here. People who are terminally online will probably, this is a multi-pack of resistors.
Sorry, let me.
Yeah. I will try not to move it around.
Ian Horner multi-pack.
They came from a brand, Bojack. Other electronic supplies are available, but as many of you may recall, Bojack is a horseman. And I couldn't just resist myself. Every time I see this particular box, my mind says very silently inside, and it's important it's in your inside voice, my resistance only makes your project easier. Anyway, like this, because they're all labeled in the bags, so I don't have to hunt resistor codes out of a pile of loose resistors of various kinds.
You mean you don't know all the codes off by heart?
Yes, I definitely do.
Shockingly, I can remember a little bit of the resistor code for the weirdest reason.
Oh, wait, and that is?
If I don't know if I told you this story.
No.
So I used to work in a gear warehouse for Showtech. And so this is like, if you've ever seen like a concert, there's like all the equipment that like, there's roadies that travel with the band, and then there's like local guys. And I worked in that industry for quite a number of years. And the people who supply the local guys work in an equipment warehouse. So it's like from somebody who's doing a wedding that needs like a couple of speakers and a microphone and maybe like a DJ setup, all the way up to like, we one time supplied all the LED panels for the Scott Pilgrim movie.
Oh.
We would pack a truck with like a list of what they need, send it out, and then when it came back, we would like maintenance, inventory, sort, and file it. And the way that we indicated cable length on all of our cables, like XLRs and so forth,
Yes.
was using the resistor
You
code.
did mention that, yeah.
Which was great because you could spot it at a distance. So 25 was like red, green. 100 was like brown, black, black. I want to say 50 was like orange, black. It's it's starting to fade at this point,
yeah,
but
The thing that DMX cables
ain't nothing to.
are which which are the cables that connect lights together that are very, very, very similar to XLR cables, but for stupid reasons are not technically XLR cables.
Stand by.
Please carry on.
But DMX cables do have a color. They have colored bands around things, and they're a standardized thing. Like a red will be a 25-foot, and a green will be a certain, and it's great. And I don't know why. And it's like DMX cables figured this out, but XLR cables didn't, even though they're technically, even though their cables are very similar. And it's like, this is a great idea. Why didn't we do this?
Oh, right, there's one more little latch that I forgot about, where you can like actually open this mechanism.
Ooh, that's kind of
Neat, huh? Wow, that
nifty.
is filthy.
Just bringing up my my circuit diagram here. 1 second.
You know what's something that I miss about electronics that I've been realizing in my sort of thrifting time is old electronics will oftentimes have a complete circuit diagram.
Yes.
And they don't do that anymore.
No, and that also makes me upsetty.
Yep, because it's anti-consumer and anti-repair.
I mean, often in modern electronics, it's all in this chip that's been epoxied to the thing. So
Well,
there's
sure,
really
like
a circuit diagram to show.
yeah, but like, there's obviously sort of, some that you would just not be able to do, or it's like trade secrets or whatever, but also just like...
It's also very rare that the integrated circuit is the thing that's going to fail.
Yep.
And so, being able to know what the circuit, what that IC is, so that you know what the pins out are, so that you know where you're testing from, that's good.
But yeah, my most recent temptation was a Lloyd's 3.5-inch reel-to-reel portable tape recorder.
Ooh, dang.
It was in great shape, actually. But I was just like, I don't need this.
Yeah.
It's really cool.
But
I
you don't need it. Yeah, I've had those
Yeah,
situations
I think
as
I've
well.
been better about that now, where it's like I will look at something, I will take a little bit of time to evaluate it and like make a call about, how worth working on a thing is.
Yeah.
The alternative is you end up being like the person who runs the junkyard,
Yep.
who's got just everything and nothing.
Your grandfather.
Oh yeah, no, that's literally my grandfather. Last man to be issued a scrap license in Ontario.
Scrappy Jack.
Yep.
Available now at your local bookstore for order. Hey, we've got a couple resistors that we need for this thing as well. I've figured them out. We need a 220 ohm resistor, which is, I believe, this one, and a 47 kiloohm resistor that's going to be our pull-up resistor for the LED. Other way around. The 220 will be our pull-up, and the other one is going to regulate the voltage to the things. Why is it not marked on this circuit diagram?
I'm a big kid now.
Now,
Oh, there it is. Yes, 47K.
now the button, because of the actual the actual functionality of the button, the wireless triggering had other electronics inside it. Like it had some sort of electronic thing to do the actual communication with the wireless system, right?
Correct. The button this year was based on the case was 3D printed, then painted with the Musso black paint to make it extremely black, then finished with future floor polish to give it a protective coating that made it less black, but made it shiny and a little bit.
Floor polish.
Yeah, it is the secret tech for model makers. It is basically the perfect top coat for a gloss coat because it just goes on super easy, is super cheap, and pools not very. It doesn't pool, but it sheets very well.
Oh.
So it's exactly what you want
I'll
for
have
that
to
stage.
remember that.
Yeah.
The top coating that I've been experimenting with is honest to goodness shellac.
Yep, that's
Made from bug stuff.
Yep, but it does the job.
Yeah, it's like
Very well.
it definitely has its quirks and disadvantages, but like it's one of those things where I think one of the big reasons people don't use it as much is because there is a very slight amount of process to it. Because like I decided to do it, it's like if it's worth doing, do it properly. So I bought actual like shellac flakes and dissolved them in denatured alcohol to make some shellac. But yeah, I've been using it for tool handles.
Oh, that's perfect.
So for those of you who don't know, shellac is made from the secretions of the lac bug, which is harvested off of, I think it's trees that they cultivate them on.
And it dries up super hard.
It's very good.
Yeah. It's a natural resin.
Yep. Some sort of secreted resin.
So we got the coating on the ball, and then inside that, it was all shaped for available from the Washington Delivery Company, an arcade button in the size of 120 millimeters. You may remember on previous episodes of Tinker Tailor Solder Fry, I've been working with these 60 millimeter arcade buttons for the pop and music controller, and that kind of gave me the inspiration for this year's button. So I got the biggest button I could find, and at the bottom of the button, where the actual switch is, the little micro switch, that had 4 blade connectors on it. Why 4? Well, 2. Actually, no, it had 5. That's right. Why 5? Well, 3 of them were for the switch itself, the little clicky micro switch that actually makes the connections. And one of them was ground, one of them was normally open, and one of them was normally closed, so that you could have it set that the button would activate on releasing the button or on the other side, pointing down. That was connected to a third-party or aftermarket automotive lock set, so that normally used so that you could attach automatic door locks to a fob to an older car that didn't necessarily come with those. So what I did is I cut off all the unnecessary wires necessary from this thing, the receiver or the car piece, and attached that to a Raspberry Pi on 2 pins via a relay to split off the 12-volt car stuff and the 5-volt Raspberry Pi stuff. When the Raspberry Pi notices those 2 pins get connected, which happens when the fob gets clicked, that sends the signals to the Random Dance Party system at Desert Bus, and Bob's your uncle, we get a Random Dance Party, and it's not reliant on having to... Go ahead.
Fob's your uncle.
Fob, yeah, goddamn.
And I mean, I think we talked about this a little bit on previous, because I mean the problem you always have, it's either you're like have some sort of Wi-Fi connection,
Yes.
and that requires a lot of power to maintain, or it has to reconnect every time, and that's a lot of latency.
Yeah, and neither of those are ideal situations.
And so you and I mean everybody really liked how much the the button, you could just push the button and it would just go.
Just works, and it has the double
And that's
benefit.
and that's actually like it's like a car door opener, so it's like a radio frequency thing as opposed to like a Bluetooth or something.
And it can go a lot farther too because it's just a simple signal. We actually had Andrew activate the button on the roof once, which was a good time.
We pretended Ben was driving the bus on the roof.
Yeah, except he was.
Sure.
The the way that was done, I just broke open the fob and soldered wires directly to the contact point, which would have been a click switch. And so now it's just this tiny circuit board that can sit inside these buttons, connect to a button switch, and the back end stays the same. I don't need to change anything out, so it means constructing a button that just works every time is super easy. Now you got to make it fun, and that's what the other two blades on those arcade buttons are for, because those connect to the LED inside of the button. Funnily enough, they're nice enough to give you a pre-soldered pull-up resistor on the LED immediately. So it's great. Draconite Dev says ESP now would be another good option too. Requires a second ESP as a hub. I'll have to look into that, but at the moment, the lack of, or the fact we don't need a microcontroller, is really great.
Because I've actually looked into this a little bit myself too, and ESP now is sort of a low power, IoT kind of.
Another one of those protocols, and
but it needs a hub in order to. So it's sort of an alternative to low power Bluetooth or something. But it's this idea that it's like, if all you need to send is go, like you don't have to you need to send data, you're just sending the fact that the button has been hit.
One bit.
Things get a lot simpler. Yeah,
and there is room for expansion on it too. The fobs that came with this one have two buttons at least, lock and unlock, so we can add a second function to that second lock button just by attaching a relay again into a second set of pins on the Raspberry Pi to monitor those for whatever we want to do with it. In fact, we can go even further because there's also the alarm button that sends out yet another signal that is interpreted by the back end to go over different wires. So there's room for expansion with what we've got, and I'm quite happy with it.
I forgot about this little detail, sorry. In this window, I believe when it's out of balls, a little anchor flag drops down.
Oh, yeah, I can see it in the back here.
So that just like...
And you just know...
I think that's also just like, no, you can't play anymore.
Game over.
So the only thing... So inside the actual device itself was just this sort of stripped down...
key fob, basically.
Key fob. And then like a little, which just has like a little coin cell in it or something, right?
Yep. And a second circuit board that was about that big, just made on breadboard, attached to 4 AA batteries. And now the reason for the 4 AA's is that the way the circuit works is that it measures the voltage that is coming back into the 555 timer via a capacitor. And so when the capacitor gets up to 2/3 of the voltage that it can hold, the 555 sends the signal to then dump the capacitor, thereby lighting up the LED. And then once it hits 0 voltages in the capacitor, the 555 flips back to fill mode on the capacitor, bringing the light, the LED down and the capacitor voltage up. And then once it gets up, it dumps, and then the light comes back on and back and forth forever.
And so the pulsing is because the capacitor kind of smooths out the on-off.
Exactly. It's acting like a buffer to the voltage to bring it back up and down.
Cool.
So yeah, we've got the 2 resistors, we've got the timer. The other components we need are a power source. So we're going to use a 9-volt battery for this today. We're going to use a 1,000 millifarad. I think I've got one more of those at least. Capacitor. Oh, you know what? I might be out. Well, you know.
Different capacitors would make it pulse at different speeds, I
Correct.
guess, right? Yeah.
And different voltages will make it pulse at different speeds. One of the things I said a few times at Desert Bus was that I tried it out with both a 9-volt battery and with the 4 AA's. And the 9-volt sped up the cycle enough that it felt like it was an anxious breathing. Sort of
Because 4 AA's in parallel would be 6, right?
Yep, 6 volts.
So 1.5 each.
Yeah. And 5 wasn't enough to get us enough brightness.
And a lantern battery would have been too big.
Probably. Well, that absolutely would not fit in there at all. So we'll try this out with, the result is going to be that we're going to get a breathing LED light. It just won't be the same rate as the other one. Yeah, let's go with this guy because I think he's the right size. But you know what we're going to do?
Next year the light breathes in time with the dance party music.
That probably wouldn't be too difficult to do by adding a microphone to it somewhere.
Next time we should make
It's like a microphone, and then like have a filter, so it's only picking up like the bass sound.
Exactly. All right. Well, what we're going to do here is I like leaving you on a cliffhanger, so I'm going to say this is the time for us to take a short break. We're going to get up, swap our fluids, stretch our legs, or sit down, some of us, and we'll be back with more Tinker Tailor Solder Fry and the construction of this circuit in just a few minutes. Don't go all the way away. Welcome back to Tinker Tailor Solder Fry here on the mighty Loading Ready Run Video Entertainment Network, where we are doing some Pachinko maintenance, building a 555 LED breathing timer, and eventually we'll get to making some sushi, I guess. All right, we've got our chip, we've got our resistors, we've got our capacitor. We only need one more piece of equipment left, and that is a transistor, which in this case we're going to be going with the BC548. Other transistors are available, and in fact I did use a different transistor in the thing that got used in Desert Bus. That one was the 2N3704. And why did I use that resistor? Or that transistor? Because I had some. And it was the wrong transistor to use, probably. So this might end up being a much different light than what we saw before. The problem with that transistor, the biggest problem, I would say, is that what they don't tell you about transistors is that they're not all pinned the same way.
What?
They have a collector, an emitter, and a third pin, which the name I cannot remember off the top of my head right now.
The Holy Ghost.
Yeah, the Holy Ghost. There we go. Thank you. The base. Thank you, Snack Pack. You are based. So, on the one I used, on the one we're going to use today, base is the central one. I believe right is collector and left is emitter, if the flat face is facing you. The one I used doesn't do that, and in fact transitions things, I believe, everything one pin to the right. So you've got base, collector, and an emitter, or I think it might even been reversed. Anyway, I spent a good 3 days trying to find out if the resistor itself was shot, if the LED was shot, if they were using the wrong resistors, if the capacitors were bad. And it turns out that, yes, as Too Many Knives says, check your data sheet. Make sure you're using the correct pins to go in and out and base your transistor.
Now, just mostly from my own memory, transistor is when you have you have a signal coming in and a signal going out, and then a third signal that tells it whether to allow that to happen.
Yeah, and will
to open or close the.
And will influence that output as well. So you may have a transistor that will act as an amplifier in that case, and in this case that's what it's doing. It's
Oh, okay.
So those are what replaced vacuum tubes, if I'm not mistaken.
You are correct. Yes.
And what also, as a sort of knock-on, allowed electronics to get much smaller
Yes.
for a reason that I didn't initially understand. And I found out through my uranium scout Geiger counter that I have at home, because it's from the 1950s, and so it's vacuum tube based. And tube-based electronics of the time needed two power supplies, a low voltage and a high voltage. And they would have specifically, like, they were called radio batteries. It was like this giant chonk.
Yeah, just 12 volts of
No,
lead
it was
acid.
like, it was more than that, actually.
Ooh.
Like, they were type B cells or something. And it's actually like 40 AAA cells in a bundle.
Yep.
Something like that.
Yeah. Well, that's that when we say battery, and we're talking about like a AA, that's really kind of incorrect because it's a single cell.
Yeah, it's some absurd. I don't remember exactly how many, but it's something like 36 or like 48 volts.
Yep.
So it's just like a ridiculous number
Do not-
together. And one of the big things about transistors is because it replaced vacuum tubes, it didn't need that enormous high voltage power supply. So
And didn't get as hot.
yeah,
and
so
didn't-
you would
And I
get
mean-
transistor radios,
Yep.
which
like-
I mean, just transistors are also just physically way smaller.
Yeah. Well, I mean, compare this to the smallest vacuum tube, which would probably be would still be bigger than this particular capacitor. Like these things are tiny. Miniaturization is real.
Yup.
Yeah. Okay.
I do kind of want to learn about vacuum tubes. It's probably a deep rabbit hole full of weird stuff, but I don't know. It's pretty cool.
They are. It's amazing what you can do with moving electrons
Yeah.
about.
Well, that was a funny little anecdote. One of my favorites from the Cold War, where I think some of the first MiGs that the United States captured, and they tore them apart and looked through them, and initially were laughing their heads off because they're like, these are all full of vacuum tubes. They're so backwards. Until they worked out, it's like, oh, these are designed to be hardened against nuclear attack. So they would continue working after an
There
airburst.
is a reason for that.
It's just like, oh, you're on a different level.
You want to bring your pilots home. That's weird.
So, you know, we talked a little bit about the sort of fame and the sort of epic history of the 555 and saying whether that's sort of more of like a marketing name than the actual description of what it is. What does it actually do? What is this chip? Why is it so ubiquitous?
So my understanding is not as complete as it should be on that, but it's there's a great site that I can point people to, if you give me just one moment here, that will give you an idea of what's possible to do with this particular chip and why it's so easy to work with. People call it a timer. It's not really a timer. It's a series of resistors and flip-flops that just make certain projects much easier. 1 second. 555. There we go. If you go to timer-circuits.com. You can see a huge list of options, the pin configurations, as well as an internal display of what's going on inside it. But I mean, you can use these things to make calculators. You can use it as a continuity tester.
So about like what is like when you connect the different pins of the 555 to things, like what is it actually doing? Is is it just a it has a certain logic? It's like a very fancy logic gate that as you know it's different inputs go to different legs and then it sends different outputs through other legs. Is that sort of?
So in this circuit, which is the one I'm most familiar with, what it does is it acts as kind of it acts as a flip-flop and voltage sensor. So I'll try to explain it as I build it together here. But you take pin 1 and that goes to ground because pin 1 goes to ground, and pin 8 on the other side is going to go to your voltage to get the power. So we'll wire those up first here. The next thing we're going to do is set the configuration mode of this timer chip, and we're going to be setting it into the unstable mode, which means that it can flip back and forth between two states. So we do that by connecting. Where is some good wire here?
You short out two of the legs. Is that?
Yeah, I guess shorting is the correct term because we are creating a short between them.
I thought that was a stock thing.
Pin 3 and pin 6, yes, are the ones that you need to connect to make that to put that into that mode that we want, that will allow it to flip things on and flip things off. So this one counts from the bottom, assuming your bottom would be 1, 2, 3, 4, all on the bottom here, and then coming around, wrapping up the edge of the chip, 5, 6, 7, 8. So we're going to connect 3 and 6, and that's going to set it into that mode that will allow us to do what we want with it.
And so if you connect, there's various configurations of connecting legs together that changes what it does. Eh?
Exactly. And then if you connect other legs together, you can have the chip self-change its modes based on what parts are being used at what time.
It doesn't actually have any like memory in it though. Eh? Like
No.
it's all it doesn't have a state. It's all based on just what it is receiving.
I believe so.
State of your component, lad. Hey, Ian.
Yes.
What's a flip-flop?
What's a flip-flop?
I'm like partly asking for myself because I think I kind of know what you mean, but
A flip-flop is one of those circuits that's set up such that it stays in one state until it receives a signal, in which case it flips over to another state.
okay.
And then you receive that signal and it flips back.
Is that dissimilar from a logic gate? Because a logic gate, when the input is there, it does something
Like
else.
you can make a flip flop from logic gates.
Yes, that's correct. Yeah.
It's a particular configuration of logic
Okay.
gates.
Yeah. The logic gates are generally, the logic gates themselves are discrete units. So you'll have your ands, your nans.
Yeah, I
your
was
ors.
always curious about that in like electronics, because conceptually I'm sort of familiar with logic gates, but are those like individual components, or is there like a bunch of them contained inside something else?
Yes.
Yeah,
Oh, I
Both.
see.
you can do it either way.
Yeah. You can buy individual components, or
Okay.
you can buy segments of them. In fact, that's what computers are made up is
It's just
a
like
large amount of logic gates.
Yeah, well, because like people who build computers in Minecraft, it's really just like a giant number of logic gates doing stuff.
Or if you're a fan of the three-body problem, large groups of humans acting as a computer by holding up flags.
I heard you can make a computer out of crabs. Like, you need a lot of them.
And you'd need to train them too. That's the problem.
Nah, that's the easy part, mate.
I remember when I was a kid, I had a game on. We had an Apple. We had like an Apple II.
Mm-hmm.
And we had a game. I think it was called like Rocky's Boot, I think, or something like that.
Okay.
But it was basically like one of these. It was sort of like, you know, the Incredible Machine or one of those type
Oh
of
man,
things.
that game was so cool.
Except it was logic gates rather than
Okay.
little contraptions and stuff. So it was like, you know, make a thing to do this, and then you'd sort of put little components together and build it through.
Okay, let me see if I'm remembering things correctly here. So we've got our bridge, we've got our power. That's 3, 2, 6. Next up, 4 needs to connect to the power as well, but it's going to do so from a different location. So
Holy crap, I actually remembered that correctly. Rocky's Boots. Why is it called that?
Wow.
An educational logic puzzle game published in 1982 and
Damn.
released for the Apple II. Excellent.
Congrats.
Okay, so 4 connects to the power bus as well. I'm sure I did this more cleanly last time.
I got another kind of obvious component question. What exactly is a bus?
That's a good question.
Right? Because I've heard it in context a bunch of different ways, like stuff like a bus bar, and what
Yeah.
I've seen of it is it's like a bunch of stuff connected in one place.
Yeah,
Together.
it's like it's like a place where multiple things can all connect to each other.
And send data, usually. That's too far. No, that's far. That's fine. Okay. So, we need to go from 4 to that, and then 4 to, I believe, the collector on the BC 548, which means I need to look up to be sure what the pinout again is.
I found a great other little thing here on the manufacturer's label.
Mhm.
There's like a rainbow sort of like slanted type that says, if you want merit, buy the Nishijin's merit.
But, what's merit?
Yes. Great value.
Do I want merit?
It is good functioning.
It am good functioning. Well, there you have it.
All right. Well,
Can't be denied.
Well, I do am good functioning.
You know, it's interesting doing thrifting for electronics goods specifically, because you have to remember that from the end of the war until, I want to say like around the 90s, made in Japan had about the same weight as like made in China does now.
Yes. Well, I'd say. Yeah, no, you're actually exactly right, given the tariff situations that are going on.
Yeah, it's like they.
There's my good.
Yeah,
good diagram.
like Japanese electronics used to be really bad.
Mhm. Oh yeah, they did, but they got better real quick.
Yeah. So it's like, I wonder if there's sort of like a tick over spot, like sweet spot. But I mean, like gosh, I wonder why that was.
Anyway,
Something about crippled infrastructure.
Now, of course, made in China is effectively meaningless because everything is made in China.
Yeah, that's the weird. So I heard there's something that I heard anecdotally, because sometimes you talk about badly QC'd Chinese parts, or things made of Chinesium, and what I've heard is that China will manufacture exactly to the specs you ask for.
Yes.
So if you are a cheapskate and you're like, I want this made really cheap and really shitty, they're like, yep.
Absolutely.
And if you're like, I need this to be really, really good and high tolerance, they're like, yep, got it.
Yep.
So
Like, there's a reason Apple manufactures in China. They can put out the the quality that they demand.
Yeah.
In fact, I mean, literally, they can't. Like, I remember them talking about that for, why don't they manufacture the iPhone in America? All this stuff. And it's like,
Well,
you have to understand, it's like, there is nowhere else in the world that you can say, like, we need 5,000, like, PhD level engineers in a month.
yeah, I mean, I guess it's just like people who don't really understand infrastructure.
It's not that we aren't willing to pay the money for it. They literally don't exist. Like, you just can't move that fast.
Yeah.
Okay.
World's really, really big now, but also very tiny.
Yes. All right. Base of this transistor needs to go to pin 2,
The base of this transistor.
which will also need to connect with the. Yeah, I have dog's breakfast this, but it'll work. Ideal. Hopefully this will work. And then pin 2 also connects to 3 via resist.
So there's a very interesting couple of little details on the back here. Most of the stuff is held in with like screws and bolts and so forth, but some of the plastic parts have been stapled to the wood.
Oh man, that doesn't sound great.
I mean, like, they're permanent fixtures, so it's not intrinsically bad.
But
it's just kind of-
repairability-wise is...
Yeah, it's like, I mean, for the hobbyist, it's like, well, that's got to be replaced.
Yeah.
Also, I just noticed that there's a tensioner here for the lever, where you can like,
Oh, you can set how strong.
yeah, you can set how strong it is by moving, and it's like it's a steel strap with holes in it, like a belt that's held on a nail.
Easy to deal with.
It's not stupid. It's advanced.
All right. So you connected pin 3 to pin 2 via resistor. And then 2 is going to the base. And 6 is going to, we need to get 6 on that same run as well. So that's
This is like one of those,
6 is on there already.
500 electronics project kits.
Okay, here's the trouble. Is we need to get pin 6, which is currently also attached to pin 3. Well, you know what we'll do is we'll just jump our... We're going to jump our negatives and our positives too. So everybody gets power on both sides of the
I
rail.
gotta do one of these sometime. Like, can you believe that? I don't think I've ever built a breadboard project.
I mean, that's not surprising to me. I mean, not because it's you, but because of the day and age is what it is. Do you know why I have this?
Why?
Because I picked it out of the dumpster at university from a first-year comp sci or electronics engineering student.
Lucky.
Yeah.
Yeah.
So that, I mean, they're not the sort of things you just go and buy these days.
Well, I mean, like, electronics is something that I would like to learn more about, and it's like a little daunting because there's some stuff that I think I grasp pretty easily, and other stuff that's like, what? Huh?
Nani?
Shirane.
Oh, yeah, that's right. I need to make sure to wire this up correctly. Negative terminal is the black stripe side on your capacitor. Do not forget. Otherwise, things will not work. Okay, and the last step then is we need a 220 ohm resistor going to from the emitter of the LED from the emitter of the transistor to the LED, and then that goes to the ground as well. And I believe, again, shorter is groundier.
I saw a really good grounding photo where they had knocked a hole in the wall to get plumbing. Oh no, it was the rebar that the building was made out of, and they grounded to that. It's like, yeah, that'll work. You're just a maniac.
Wait, why were they grounding down to the rebar? Oh, no, they're grounding it to the rebar. Oh yeah, no, that's fine.
It's one of those, I guess.
Like if you want a piece of wire that's attached to Earth, that's
that thing where you open the electric cabinet and there's like a little glass jar with some dirt in it.
I was just thinking about that, Paul. Or like a bucket of soil.
Yeah.
It's like you've misunderstood the exercise.
all right. Let's see if I've got this wired up correctly here. And if not,
What happens if you're not?
well, it just won't go on. That's the nice. Oh, hey, there we go. Okay.
It's alive.
So that says to me we might have our.
Is it just very, very dim?
It is dim,
Well, it's like one LED power in a studio.
but it's. Yeah, there it is. You can see it is on, but it's not flashing. And I think that means I might have my transistor backwards. So let's try that.
It's not one of them PEBCAC things, is it?
Oh, it almost always is.
Yeah.
Okay.
Number of people in chat Googling PEBCAC.
So that is not my problem, I don't think. Where is my...
Right, because right now it's just steady on.
Yeah, so that's correct.
I don't suppose you have any light blue paint.
I have 0 paints with me today,
Okay.
unfortunately.
Yeah, because it's just occurring to me that like a couple of these things could use like a very careful, delicate little repaint. But I can probably do that at home. Actually, I bet you Posca markers would be great for this.
Oh, yeah.
Could
They'd
that
be
be
very, very precise?
that like the capacitor is too capacitor-y?
No, this is a much smaller capacitor than I was using previously, so if anything, it should be going faster.
Or is it going too fast?
We should be seeing some form of fading, is what I'm saying here. Just checking make sure I've got all my connections correct. So, 1 good ground, good. 3 to...
And
let's try taking that that resistor all the way to 6.
the chip is definitely the right way around.
Yeah, we wouldn't be getting any light at all if it wasn't
Okay.
going on. This is something I've learned from experience recently.
Man, I hate those kind of faults where it's just like it's not working and you can't figure out why, and then you realize it's because you're a ham sandwich.
Well, that's what happened the first time. It was wrong pinouts on the transistor, and the minute I fixed that, everything.
I remember I was trying to fix something and I had a moment like that where I was just like, oh, for heaven's sake, and like I had it upside down or backwards or something like ridiculous like that.
It's the physical electronic version of the like programming off by one
Yeah.
error.
Okay, I'm just gonna make another jump here to level 6 on that resistor.
Level 6.
Not level 6. Oh, it's empty.
Is this a variable resistor?
No, this is just this is just the 47 kilo ohm resistor. But that didn't appear to do it. So let's try what I had
That's
before.
a lot of ohms, me.
It's got to go to 2. Yep. Okay. So 2 is correct. 2 needs to be in the bus as well. And then that goes from 6 is the pin there. The capacitor goes to through the capacitor to ground.
The signal on the bus goes yes or no, yes or no, yes or no.
Right. And then looking from pin 4, that goes into the collector side. Yeah, let's just switch those two.
Hey, Ian, do you want to do a stream one of these days about cable lacing?
Haha, that could be fun.
Yeah, I would like to learn. So,
What? So why did that go on before you plugged in the second cable?
Yeah, I may have something off here then.
Like,
So,
with the green one unplugged, it still was on, which seems weird.
yeah, 2 should be going to the collector. Okay. Good. And then, no, 2 should be going to the base. Yeah, oops. But yeah, okay, good. And 4 via 5-volt. 4 to the collector side. Okay, that turns on the LED. Great. And then 220 from there to there. And then 2. But 2 is also connected to. Oh. 2 is also connected via the 47 k ohm to pin 4. I think I'm not bridging 4 and 2 at all, which is might be my problem. Okay, that just made it brighter. And the capacitor is not doing anything right now. Okay, so we're halfway there. It's just it is properly using the capacitor to fade the light down, but we're just not.
Oh yeah, I see that.
Yeah, not getting it on the inside. Ooh, what did I just do there? Ah, I knocked the power out. All right, so what am I doing wrong here? Pin 1, go into ground. Great. Pin 3, bridging to pin 6. Great. Let's unplug that, see what happens. Okay. Pin 3 to pin 6. Wait, 4, 5, 6, 3 is that one. Good. That also connects from pin 3 to pin 2 via a resistor. Let's rip those out and just do it nice and cleanly. So pin 3 goes to pin 2 via the resistor. 2 and come on, get over here. 3. Oh. Okay, that's all connected now. Oopsie. Okay. Now pin 2 is going.
It's dimmer than it was before now.
Yes, because I think we're not doubling up on anything. So pin 2 connects to 6 as well. So 2 and 3. And so I'll need to take that over there. Let's see, put 2 in there, take that to 6. Okay. That is dang cool.
Sorry, this is. If you wanted to go to the wide for a second, Paul. This is one of those things that I saw in like a thrift store, and I was like, "That's stupid." Wait, is it?
Turns out not.
It's a Black & Decker auto tape, no promotion. It's just a tape measure that has a motor assist on it.
Love that.
So it's silly until you realize you're up a ladder with one hand free, and you're like, how tall is that? I think I need new batteries.
I wasn't putting this on
that is-
pin 6.
I swear those were new
Was it?
batteries.
4, 5, 6, yeah.
I'll have to get new ones, but yeah, it's kind of cool.
What does it take?
4 AAAs for some
4
reason.
triple. Interesting
Yeah,
choice.
I don't know why.
Yeah, you can get rechargeables in that.
Oh, you know what? These might have been the ones that came with it, which would explain why they have given out almost instantly.
Yeah.
So I'll have to get some decent ones.
So now you're actually bridging with the resistor.
Yep, because I can do that. But I still want to go 3/6 directly too. So. Okay. So pin. Wait, that's 3 goes through resistor to 6, and then 2 to 6 as well. So we'll bridge that. 2 to 6. Good. Okay. 2 to 6. And then everything should have been working by now.
Classic.
Yeah. Ground, power.
Wait, is the red one? The red one's ground?
Red one is power.
Oh, I see.
Yeah, green one is ground on this one. Pin 1 is ground. Pin 8 is
Right.
powered. And 4. Right, that might be where my issue is. Pin 4 also needs power. So let's give that power. Okay. Oh, wait, there we are. Oh!
We're back to just on.
Yeah.
And it, oh, wait, it sort of faded on, and
Yes.
when you disconnected it, it faded out, and when you connected it, it faded on. But it's just not doing it by itself.
Yeah, which means we may have some voltage issues here. Let's try a different capacitor just for funsies' sake. Turn off, turn on. Okay.
That's just blinking.
Yeah. Oh, do I have that backwards? I have it backwards, that's why. Capacitor is on pin 6. 6 and... So you can see lower powered capacitor, definitely smaller, smaller output.
Wait, why was it still lit up when you took the capacitor out completely?
Because then it's bypassing without the capacitor. Right off there. But if we put it back, we get that nice fade out. So that tells me there's something I don't have the chip hooked up correctly somehow. And unsure what happened here. Whoops, there we go. Yeah, there it is. It's on. And it fades up So this,
So it fades up and it fades down, but it just doesn't do it automatically.
yeah, and I'm not sure what's happening there.
It's like the flip-flopping is not flip-flopping.
And you know what I didn't do is I didn't bring my who's it?
Multimeter?
Yes, my multimeter. Thank you. So that could have something to do with this as well. Oh no, it is breathing. We did have it right. It's just very slow.
No.
Give it a second. Give it a second.
Almost. Almost.
I'm pretty sure I saw it go out.
It'll be like the pitch drop LED.
Yeah, there he goes.
Oh yeah, there we go. Here, let me take down the studio lights here.
Yeah, please. This is an extremely slow version.
There it
Yeah,
goes.
there it goes.
So it's not like it doesn't go sort of smoothly in and out. It stays lit to a certain point,
Mm-hmm.
and then it fades out, and then it fades back, and then it stays lit.
Yeah. So actually, you know what I'm going to do here, just for fun, is I'm going to swap into the transistor that I used before. I believe I've got a second one of these.
So is that because you're using the 9-volt rather than the thing, or is it because the capacitor is different? Or?
It could. I mean, I've got so many things that are different on this one. We've got to note the things that are different. The LED itself is different because the LED is too big to fit in the button. The pull-up resistor is different because the one that I used was pre-soldered and pre-connected to the LED inside the button. The transistor is different because we're trying the one that they suggested in the circuit diagram rather than the one I had on hand. And the capacitor is different because I only had one 1,000 microfarad capacitor available.
So from a scientific method standpoint, this is just a shambles, is what.
Well, the circuit it works, and I think that was the main thing. 2N3704.
So presumably there's like I would imagine there's like a table somewhere where you can see like if you have, this power supply and this resistor and this capacitor, you'll get this speed versus this. Like there's is there a sort of a standardized?
Interestingly, what I did when I was experimenting, the site that pointed me out to this particular project, which is on Instructables, had a link to one of those circuit simulation sites, which was very nifty because it meant I could actually see how the circuit's working, how it's pushing the electrons through the one part until it gets
neat.
the voltage and then it drops. And in that, you can actually input different values for your transistor and your resistors and your input voltages and whatnot, and see how fast it's going to start blinking. So
It would be cool to put in all these numbers and see if it represents the accuracy, if it represents an accurate simulation of what we're seeing.
Mm-hmm. So that doesn't seem correct. 2N3704. No, I want the pinouts. Give me the pinouts. Okay, so base is pin. Yes. So on 3704, your base is pin 3. Your emitter is pin 1. Your collector is pin 2. This is not normal.
What?
So it's deep power here.
Why would you do that?
Yeah. Apparently there are two different types of pinouts, and those are the two of them because we can't have nice things in the world.
I put it to you, if there are 3 wires and there are 2 different ways that it can go. I mean, I guess 3 different ways it could go is the only worst way, but it's like, I put it to you, that's not a standard if it's different.
Mm-hmm. When you have two standards, that's too many standards.
We have too many standards. We should
but-
make a new standard that unifies everything.
No, we should just decide which of the two to go with and stick with that one. It's like if there's only 3 wires and there's 2 ways of doing it, then yeah, you're already way behind.
Let's see if a different size capacitor makes any fun here for us.
Yeah, no, I don't want to create a new competing standard. Just stick with. There's so many things in life that, in the world that I don't care. It's like I don't care what we decide on. The world would be so much nicer if we would just decide on one. In terms of standards, I'm perfectly willing to change. The one that I grew up using.
Yeah.
If we're all going to agree to use a different one,
Just give me one.
if we all want to, if we could all switch over to say, using like the A4, the paper sizing system rather than the letter paper sizing system, that would be fine by me.
But we just have to all agree.
But we all have to agree.
Look, we're doing this. It happens tomorrow.
Yeah.
Get ready. Okay. So playing around with different capacitors is, I think this one's probably the best at the moment. It breathes up and breathes down pretty.
Oh, that's a little one. You have a
Yeah.
little different.
And this is with the different transistor. In fact, just for fun, let's put in the one we had initially, and just see how fast it goes up and down for us. Pin 6. Okay. That feels like something. Again, it would be nice to be able to touch it with the multimeter and show you exactly how the voltage is changing over time. It's quite fascinating. But yeah, what's happening here, just to remind you, is that we're the chip in the center is basically keeping an eye on the voltage in the capacitor right now and comparing it to the voltage it's getting off of the right off the power levels. And so what's happening is the capacitor charges up to 2/3 of the 9 volts, so 6 volts. It switches the mode on the chip over to start dumping power through the LED, or rather down to the transistor. That helps pull up the voltage to bring it up to lighting levels. Once it's discharged down to 0 volts, the chip swaps over to charging mode on the capacitor, pulling power from the LED side of the circuit and charging the capacitor back up and fading the LED down.
I got another ding-dong question.
Yeah.
What differentiates a battery from a capacitor? Like, they both serve a similar function,
Yes.
but not the same.
Capacitors, my understanding with capacitors is that they are harder to keep charged
Okay.
than they are, and discharge rate is another issue.
They basically accomplish the same thing, but on different time scales.
Yes.
In fact, there's been research into using what are sometimes called supercapacitors for things like phones and things, where it's just basically like it's like, hey, we can charge a person's phone in 30 seconds
Instantly. Yeah.
just by just jamming a ton of voltage into it. There are reasons for that not being a good idea.
I mean, we're already carrying small incendiary devices next to our heads. Why
And-
not?
And filling our roads with them.
But yeah, the idea, and capacitors don't maintain charge after they've been. Well, no, they do, but
Yeah. But there's a slow bleed off, but that's the same as a cell as well.
yeah, it's true. Yeah, I guess it's just a matter of like, capacitors are there's sort of different orders of magnitude in terms of time to charge and time to discharge.
Yeah, it's really a question of, how as you said, speed. How fast do you need this thing to charge? How long do you need it to stay charged?
Gotcha.
So for, like a small, someone mentioned smoke alarms are a good place for a capacitor if they're in a building that's run by central power.
Yeah.
So they can keep itself charged and keep itself going for a short
It's so
time.
wild how, and I believe this is the correct understanding of how smoke detectors work, because they have a radioactive source in them, which is mercifully now quite small, and it has like an inverted detector that is continually like receiving the neutron emissions from the source, and when those neutrons are blocked by smoke particles,
Yep.
then it goes off.
Yep.
Which is why like steam from a shower can set it off.
Interesting.
Sometimes, yeah.
Yeah, the Soviets made ones with plutonium.
Oh, that seems like a much better use for plutonium.
Not really.
Actually, I'm going to shout out to Mercano here. We've been talking about the functional differences between capacitors and batteries.
Oh, yeah.
But one of the fundamental differences between the two of them is that capacitors store power via opposite charge attraction between two plates, and batteries store power via chemical reactions.
Yeah, okay. I watched like an ephemera film from, I want to say like the 50s or 60s about how lead acid batteries actually work.
Yeah.
And it's bonkers.
Yep.
So like, I don't know if you, I mean, this is like a related tangent. The very
Absolutely.
first batteries, called a battery pile?
Yeah,
electrolytic pile?
Electrolytic piles in Iraq and the Middle East.
So they consisted of alternating like wafers of metal and then
Galvanic pile. Yeah.
cards, like some sort of card stock, and the whole thing was like soaked in a electrolyte.
Yeah,
Like
so
a
you've got
weak acid.
electrolytes coming between your two different
Yeah.
types of metal.
So the battery relies on the difference in types of metal.
Yep.
So like that works, and it would create a small charge. Lead acid batteries, they use one type of metal, which is lead, and it's like, well, how does that work? How does it behave like two types of metal? Well, it does, because it converts into was it lead 2 oxide? Which
I think you're right, yeah.
Which behaves in the same sort of like difference between metals that
Electrical.
Yeah.
Yeah. The
and like
ionic
the
difference.
amount it is transformed into the other sort of loosely correlates to how charged it is.
Yep.
It's like, what?
It's actually quite interesting. You mentioned the galvanic piles too, because those are essentially how modern cells are made as well. You're just taking a long amount of two separate metals separated by a soaked,
You just get them really,
Electric?
really thin now?
and then you need to roll them up, and that's why cells are round. And that's why when you put cells together, like 6 tiny cells into a 9-volt battery, they get square in that size. But if you break it open, you'll find the 3.
Yeah,
the
I
6
didn't
round
realize
bits.
that. Like, I used to think of it that like 9 volts were, like this is one battery, but it's like, no, it's secretly 6
Yep.
AAAs.
And that's why this one is a battery and not a cell.
Quadruple A's, in fact,
Yes.
Oh, really? Quadruple A's. But yeah, that was like,
which don't exist inside other batteries.
yeah,
I
that
don't
adds
think.
up. Like 1.5, 3, 6, 9.
There you go.
There you go.
All right. What you got left to do here?
I'm looking for places to clean, and I think I've hit all of them. I started gingerly trying to dismantle parts, but I'm poking very carefully. At this point in the disassembly, there's so many like kind of like interconnected components that I think I would have to, fully pull it apart. And it's probably things that are not even that dirty, and it's just like working. So
Not going to throw any of it through the dishwasher, then I take it.
this wouldn't fit in my dishwasher.
And a lot of wood too, which I
Yeah,
probably.
I have 2 screws that I don't know where they go.
Oops. Well, thankfully they're not matching, so I think you're probably
That's
safe.
not better, Ian. So, okay, that one's accounted for. That one, that one. That one, that one, that one, that one, that one, that one.
I think a screw goes there. at some point? No,
It's
it's not
not
hold?
not threaded.
How about there? That also looks like it might receive.
That's also not threaded.
Okay.
So like this is on. I hate this.
Well, if any of you know where Alex's screws go,
That you didn't see me removing because it was away from your camera.
feel free to hit us up on the Loading Ready Run Discord, where you can connect with members of the channel and also chat with other fans about everything that's going on this channel, which is actually a lot. We do a lot of stuff here.
We sure do.
Yeah, but I think that if we're done that and we're done this here, I think we're going to have to call that an episode of Tinker Tailor Solder Fry. We're mostly successful, I think, which is continue the successes.
Yeah.
And we'll eventually get to that sushi one of these days.
Just a couple extra screws.
Yep.
Do I have time for a quick preview?
Absolutely.
1 second. Let me.
I'm just imagining next time somebody fires the like ball release thing, it just like fires and the entire thing falls apart. Just
So. This is a preview of
yes.
a future episode. I've been working on a thing, and this is the first version that I made. So, metal benders, like universal benders, are shockingly useful tools.
Yes.
And so, I wanted to make one. And so I made.
Lord Hosk thinks they may have the answer for you.
To what?
Where
on
your
the,
screw goes.
on the side that we can see right now, there appears to be a hole in the wood that doesn't have a screw in it.
That's actually where I screwed up and like put in a screw that wasn't going to work.
Neither of Alex's screws in his hand were countersunk. Add
Yeah.
that to your information.
I'll just have to figure it out. Okay, so I first made this, which
Right.
is a really, really simple bench bender
Oh.
that I enhanced a little bit.
Okay. What happens if I put my finger in
Don't.
here?
See, if I was smart, I would have come with something to bend to show you how it works.
Hey, bench bender.
Oh, this might work.
What's your blender? What do you got there? Is that the rod? Yeah, it's the rod. I think that's your rod anyway. So you do with that as
okay.
you please.
So, what is this? It's a fixture that applies a measured amount of force. Because I'm sure people have tried, bending metal using like pliers or a vise or something, and it's a pain in the ass.
Oh,
and
it's
it sucks.
terrible. Yeah, inaccurate, hard to do to the correct amount.
Yeah. So this is applying your muscle force in a very measured way. So if we take, the,
This is one of those times when iPro is probably a good idea.
It's a slow operation, so it's not that bad. So if I place something like, say, this round stock into here, and then tighten it, what we have here is like a pivot point and then 2 points that will hold it.
And hold it flat and
Hold it
steady.
like flat and steady. So when I pull on it, it will draw the stock,
Oh, look at
around.
that.
and we
Now,
can do stuff like,
I guess a more advanced version of this would have some sort of markings on it so that you could, measure.
yeah, you can also do the marking. So I also, these blocks here, you'll notice they have an off-center hole, so they can be turned to fit closer or
different-
further away from the
right.
stock. So if I move it closer, now I can sort of finesse that bend and make a nice little hook out of it.
And now, it's just, now
But
you
you
have
can
a tent peg.
You can use this for round stock, but also for bar.
Yeah, flat stock. Like this one is really basic and limited. So I can do now we can.
Yeah.
You start to get the idea about like what you can do with this.
Well,
It's
this
like,
is very, very useful for doing custom springs of a specific length.
yeah, you could do that. So yeah, this is just like a very rudimentary kind of thing. The reason I show this to you is because I'm dead chuffed that I actually was able to make
cool as
this
hell.
out of various things. It was a lot of like milling and drilling and so forth. But I have already been hard at work at a sort of a sequel, which is a half-size Hausfeld bender number 2.
Ooh.
Which I'll show at some point, and it's fun because it's in a functional state now. I just need to make a lot more tooling, because if you imagine this, but like more complicated and more adjustable, and more capable of bending more things.
For getting extremely precise bends.
Just like different sizes and different like dimensions, and what the big deal is bending tube. Because if you've ever tried
Without
bending,
crimping it.
exactly, that's what manual benders that have dies in them are good for, is because they support the bend, so it will like bend smoothly and not kink.
Yeah, because as you
otherwise-
say, you use the correct term, drawing the metal, because
Drawing.
that's what you're doing when you're pulling out that one edge and hoping that other side stays nicely compressed.
But yeah, this is a way of cold bending, as opposed to hot bending, which is just like you heat it up and then
Yeah, just
you can do a shocking number of things with this. So that'll be fun.
yeah, fantastic.
It also,
Gonna
like,
have so many coat hangers.
right? Yeah.
Ooh,
You can make all kinds of hooks, and this also just like breaks down into like teeny pieces.
oh, more wire hangers. All right, folks, that's going to do it for this episode of Tinker Tailor Solder Fry. Thank you so much for watching. If you like what you see, don't forget to check us out over at patreon.com/loadingreadyrun, where you can help us keep the lights on, keep the shows coming, which all will get pumped out to youtube.com/loadingreadyrun. You can find links to everything we do at loadingreadyrun.com. If you put store in front of that, you'll get you'll get some nice surprises of how commerce works for us and for you. It's something we do together. So for myself, Alex, and Paul, thank you so much for watching. We will see you in a fortnight, never in fortnight, ever forward, learning out of spite. Good night.